In our previous lesson, we talked about the importance of student-generated representations in terms of their mathematical development. However, we're going to want to see some real progress in those representations. Just because it's their own thinking doesn't mean that it should stay the same all year. We need to see measurable growth in the way in which they're representing mathematical ideas. We want to see an increased use of symbols, such as numerals, as part of that. We need to see greater efficiency. We also want to see them using their mathematical representations as tools for developing mathematical insights. That is unlikely to happen without the influence of a teacher in the classroom. So that's what this lesson is about. We're going to talk about how teachers can use tools, representational tools, to help foster children's growth and development in terms of their own representations. Because we're talking about student-generated representations and teacher-generated representations, it gets a little confusing. So I wanted to stop for a minute and just talk about who's doing what. Students are using their own generated representations as a tool for communicating their thinking and to make sense of mathematical relationships. Because if we prompt them to do what we're doing, then there is the real risk that if we use that for assessment, we'll get a false read on the child's mathematical development. We also will have deprived them of the work that they have to do to try to think how to take their messy mathematical thinking and turn it into some means by which they could communicate to others. Also, we want them to use representations as tools for searching for patterns, and as teachers, we can influence that process. Teachers use representations then to reveal mathematics. We want them to see mathematical ideas, and as we look at some representational tools today, I want you to really think about how those tools might reveal mathematical concepts to children. We also want to model useful, more efficient representations and more abstract representations in a way that they can connect the new, more efficient abstract representation to the thinking that they already have and which they've already made sense of. Here you see in these quotes the importance of building connections. All too often we get really wrapped up in a tool that we're using and we're thinking of the tool, such as a number line, as the end goal. In reality, it's the connections between their own thinking and this next tool that's on their horizon in terms of being a little more abstract. The connections they make between their thinking and this tool is more likely to be a fruitful area of intellectual growth than just in using the tool alone. So the connections that we can support them in making between mathematical representations can be very powerful. And in the process, we want to also help students along a pathway towards growth by starting with their concrete thinking, shifting towards pictorial representations that are a little bit more abstract, and eventually into numeric symbolic representations. So we're going to look at what kind of criteria we should use in choosing representations, because this particular presentation has a number of my favorites, but it is not a comprehensive list. There's certainly other representations out there. And so I want you to think about what makes a good representation. So we'll talk about some criteria. As we do that, however, the goal is not for you to choose one good tool that you really like and use that all the time. I would caution you against that, because each representational tool reveals something interesting about math, but not everything interesting. And so the kind of tool that children use, if they only use that tool, it's very unlikely that they will develop a different kind of understanding. So for example, here you see a number path, which is the multicolored number line there. This number path is an appropriate number line for kindergarten children. The points on a line model is not. I don't have time to go into that right now, but research is very clear that that is too confusing for children prior to second grade. They develop misconceptions about the number line. But a number path is appropriate. Now, if I model students' thinking on the number line, children are likely to see how they started at one point, how they're moving forward and backward in the number system, what's one more, what's one less, what subtraction and addition looks like in terms of navigating our number system. So they really have almost I think of it as almost a geographic sense of number that can be developed through the use of the number path. So that's really effective, but it's not everything. The number bond in the upper left-hand corner is useful for helping students see how total numbers can actually be partitioned into two smaller groups. And I could, this one uses numerals, but I could also have put 5 dots in the top and 2 dots in one and 3 dots in the other. Whatever the case, any quantity can be partitioned into 2 smaller quantities. And so the number bond makes that very clear, and that's an additive subtractive relationship. If I know both of the parts, but I don't know the all together or the total, I have addition. If I know the total in one of the parts but not the other, that's what subtraction is. So that number bond can really help students see that aspect of addition and subtraction. And then the math rack, which you see in the upper right-hand corner, is built on this idea of 5s and 10s as benchmark numbers. And so you can see that your work with that could really play into place value and understanding the base 10 nature of our number system. These representations you see all have their strengths, but they don't tell the full story. And that's why I'm suggesting that you do not just use one kind of tool only to the exclusion of the others, but instead you apply some specific criteria in determining whether it's a good tool to use. So these are some questions I ask myself. Does this tool allow for a concrete pictorial to abstract learning progression? And some sub-questions that fall from that is, what kind of representation could I use that's going to be most likely to connect to the student's current thinking? And it's a natural progression from that thinking, so they'll be able to make the connection more easily between where they are and this next representation that I'm showing them. There will not be too big of a leap. The children will be able to perceive that relationship between the two different representations. I also want to make sure that the tools that I'm using will help to reveal mathematics to the students. So I want them to be able to reveal particular mathematical insights and relationships. Now the math rack, as an example, I already talked about this, has some specific 5s and 10s kind of relationships, and that gets at the number and base 10 standard for kindergarten. You can also model all a 10 and some leftovers and model the teen numbers, very much the number and base 10. You can model decomposition and thinking of groups as 2 different addends, or a whole number as being 2 different parts. That can be modeled on the math rack. You can also easily see a group of 10 as a full set of red and white, and you can partition that into a 1 and a 9, an 8 and a 2, a 7 and a 3, a 6 and a 4, and a 5 and a 5. So that gets at standard 4 about knowing all the combinations of 10. So you see the math rack has a number of important ideas that are evidenced in the Common Core standards as well, and would also be important mathematical ideas. I want to know that the tools that I'm using with the students are flexible, that it can actually grow with them. And so here I've used the number line as an example, although there's some ways to think about this with the other tools that I've shown as well. The number path is an appropriate tool for kindergarten. By 2nd grade, it will shift to the number line that you see below that, where it's more of the points on a line model. And then eventually we'll be able to use the number line to model fractions, negative numbers, and decimals, as well as rational numbers. I want to know that the tools that the students are using will require them to make some decisions. I mean, I can demonstrate how to use it, but when they go to use it, they have to make some decisions about how can I use this to represent the kind of thinking that I have in mind. And this is important because it keeps children in a mindful mode rather than in a mindless, I'm just following the steps mode. So here I've illustrated this concept with a dot card, and in the dot card we see 4 dots at the top and 3 dots at the bottom. So the first child says, oh well, the card you just showed us had 3 in the top and 3 in the bottom, and so I knew, we talked and 3 and 3 was 6, so I already knew that, and here there's just 1 more dot, so it must be 7. The second child said, actually, that was the second child. The first child says, oh, well, I saw 4 in the top and then 3 in the bottom, and I put 4 on this hand and 3 on this hand, and then I just counted them up. And then the third child says, well, the 4 in the top is like my dice at home, so I knew that was 4, so then I just went 5, 6, 7. So you see 3 different ways that children thought about it, in each case connecting this tool to their thinking and using it accordingly. So now we're going to just stop and think about the 10 frame and whether it fits the criteria. Is it a tool that we could use in a concrete to pictorial to abstract learning progression? Well, I think it is. For one thing, the the actual dots in a tens frame mean that children who are still counting by ones could do so, but the inherent grouping in rows of 5 and groups of frame that makes 10 is going to be useful for helping them understand some more abstract elements of our number system, which is that it's base 10, and 10 is a very important number in our number system. Does it reveal important mathematical insights? Yes, as I just mentioned. In addition to that, I've shown that it fits several of the kindergarten Common Core standards, such as on the top, being able to decompose numbers, seeing 6 being represented, you can tell automatically that's a 5 and 1. And several students, if you elicit their thinking, will think of it in this way. You can also think easily about the different combinations that make up 10. Even when my younger daughter was in preschool, I played games with these tens frames. I was amazed at how quickly she could tell what more was and what less was from using these cards. And by the time she started kindergarten, she could look at a card and tell me what the combinations of 10 were. She hadn't internalized that yet. And then also being able to see 2 tens frames can represent a 10 and a leftover, the teen numbers, as being the kindergarten number in base 10. I also want to know whether the tool can be abstracted, can be generalized into a more abstract system. So here I've shown this as an example. The number line we've already talked about, but the tens frame, how does that get abstracted? Well, in first grade, they're going to have to make 10 as a strategy that's named in the Common Core. And that means that when they see 9 plus 7, they're supposed to be able to think of it as a 10 plus 6. And that is very abstract for students. But they can use the 10 frame to make a leap to that abstract notion by seeing that a 9 is just a 10 frame that's only 1 short. So they can take 1 from the 7 frame and give it to the 9, and that will turn it into a 10 and a 6. Their work with these tens frames fosters that abstract leap. And then you see the math rack. The ones I've shown you so far have been 2 rows. This one shows all the way up to 100, and it can influence the way you think about place value through all of the double-digit numbers, eventually being abstracted in your mind so that you can think of it in those terms. So here's a list of some common kindergarten representations. Concrete, pictorial, and abstract are classifications, but it's really more of a continuum than discrete categories. So you'll see that you can start with things that look like the actual materials or are the actual materials. If the problem is about people, you're acting it out with people. If the problem is about muffins, you at least have pictures of muffins, if not real muffins. Eventually, children get to the point where they can use blocks and more generic counters to represent anything, flowers, cars, people, whatever. And then they get to the point where they're using counters that have some inherent groupings. For example, tallies that are a group of 5, or 10 frames that represent 10, math racks. Pictorial representations include visual representations, number lines, number bonds that have some of the actual objects inside them, such as having 5 dots inside it to represent 5. And eventually it can get incrementally more abstract by replacing that with a numeral 5. And then at the highest level of abstract for our kindergarten students are using numeric expressions such as 2 plus 3 to represent a group of 2 and a quantity group of 3 being joined, and then equations. So the key idea is we want to use multiple representations that will support all of our learners in developing deeper conceptual understandings and gaining insights about math, revealing the mathematical meanings. We want them to be useful tools for children to make sense. The use of the tool is not an end goal in itself. Its purpose is designed to support children in making sense of math. We also want them to be connecting representations, comparing and contrasting, seeing how this representation models something that you've already done, using them as a tool for mathematical dialogue. We do want to be careful how we sequence them, though, because our ultimate goal is to make sure that we are extending children from a place where they're already making sense, their original sense-making. And that's where we get this concrete to pictorial to abstract progression. So as we think about how to use these representations, I have several suggestions for you in thinking about how you incorporate them. And we're going to get to those in just a minute. I'm going to skip over this pretty quickly because it actually represents a couple of different pages in a book. But it was just to give you an idea that you can start with a pictorial image, such as the one of the birds flying to show subtraction. This could also be acted out in concrete ways with children performing a little mini skit. Being the birds. This is actually a first grade book here. You see them using a partial number path to model counting up and counting down, and then that's connected with the oral language, what it sounds like when you count up and count down, and then that's connected with the equations, connecting the number path to the equations. So you can see how there's making some connections, and I just showed you that to give you a quick curricular example. Okay, some suggestions now for how we facilitate the expressions and equations. Well, we're going to begin with a few don'ts, and one of them is don't get started with this right off the bat. Children have some serious work to do in math before they get to equations and expressions in kindergarten. We really want to make sure that they've got the counting cardinality down pat, and we want to make sure that they have had experience effectively modeling additive and subtractive situations using concrete materials. We want them to be really comfortable with the idea of acting things out and what these concrete materials represent in the problem before we take that even a step further and put some numerals with that. We also want to make sure that equations and expressions follow the time where we've already noticed that children are using numerals in their representations. Those numerals are beginning to have meaning for them. They are labeling their sets. They're giving their totals as numerals. And so that's important. Now, mind you, we can actually model that first. Before we model expressions and equations, when students share how they were thinking, we can actually be modeling how to put a numeral label to that afterwards. And that can be our abstract component. So those were the don'ts. What about the do's? Well, we do want to make sure that the very first time children see expressions and the very first time children see equations, that it isn't something they've plunged into, but it is actually the end part of a whole concrete to pictorial to abstract progression where this children made sense first. Through the concrete. And then we modeled that through some kind of a representation that was visual perhaps, and then from there to abstract, all the time making connections between things. We definitely want to model writing expressions for quite a while before we expect the students to do it. We're not going to just model it one day and say, okay, that's what I'd like you guys to try today. No, we do this for quite a while. Mind you, if we start doing this daily for 2 weeks, you'll see some kids already within 2 weeks who will start trying to do it just because they've seen you model it regularly and they're kind of curious about that. But you'll see others who aren't ready for that yet. So have a fairly lengthy modeling period before you expect the students to try to do it for themselves as a expectation. Writing the expressions then should also follow the work that children have already done. Remember, we always want to work from that place where children have already made sense towards the next level of abstraction. So if children have already solved the problem, they solved it in a way that made sense to them. They made their own representation. Then at that point you can say, all right, now let me show you how a mathematician would write what you just did. Because you've done some significant work there. So let's see how a mathematician would show what you just did. And then after you show it, you're also going to make connections back to what you just did. And say, so when I wrote this here, why do you think a mathematician would write that? How does that connect? Show me the part that you did that connects to. Timing is really critical as well. If you show a representation at the beginning of math class and then the students go to work, there is a real risk that children will try to do it to mimic you, even if you didn't intend it. If you were just saying, oh, I'm going to model this for several weeks and they don't have to do it yet, they'll start doing it because it was right at the beginning of the class and they thought there was some sort of tacit mandate that they should do it. And if they're doing it at that point in time trying to mimic you, they're not necessarily making sense of it. So research shows that is a real risk. Worthington studied early children's representations and has found this, this is her finding. So her suggestion is to actually model new representations and varied representations at different times of the day. For example, number talks during the morning meeting, or if you want to show a representation at the end of the lesson where it will be tomorrow before they have an opportunity. That way students still perceive that they are making their own decisions about how to use representations, and on their own timing, as they make sense, they can incorporate them. That time is well spent, because if you take the time to really study students, think about what concepts they have, assess their work, determine in the right moment to proceed and towards incrementally shifting them towards more abstract representations, you're much more likely to build a robust foundation that they will need to grow as young mathematicians. Here I've shown a sequence of 4 representations, and I'm not suggesting that you follow this exact sequence of 4, or even that you do 4 in one lesson. You might do 2 or perhaps 3, and it may take a while. You may be in 5 lessons into addition before they even see anything like that. Actually, you'd probably be much further. But even if you were trying to teach that, it's going to take a sequence. So here you see how children are likely to direct model it by building a set of 3, building a set of 2, putting them all together and counting again to 5. And it appears that this representation is part of a word problem about Kelly and Jarrell. So let's just say these are marbles, Kelly's marbles and Jarrell's marbles, and how many do they have altogether is the total. So initially, and this won't be the first time I've shown them a number bond, they will have already had experience before I show this to them. But I can use concrete representations inside there. This can then shift to using numerals. And then eventually, not all in the same lesson necessarily, but they can make a connection between the number bond and the equation or the expression. Again, making sure that children know what each of these stand for. What does the 2 represent? It represents Jarrell's marbles. It's not just a meaningless symbol. What does the plus mean? It means that we want to know how much altogether, so we're going to join those 2 sets. So you're going to want to involve the students quite a bit in making meaning of those connections between different representations.